I'm going to go over some of the homeworks on 5.6, ratio and root test. Now, I assigned number 325, but I must apologize, I kind of misread the question. As it was posed, this one is a very difficult one, and I really don't want to explain it to you because you're not going to learn anything from it. So instead of, so I'll write it up here that you don't feel bad. So 325 is cancelled, and instead I'll do something that I thought it was, and let's write this one. So instead I do this one. Okay, so it's a replacement, right? So don't say, oh, what is this now? Okay, so I thought it was pi divided by e to the power n. Honestly, because the difference was the pi was an n there, that makes it extremely difficult. And I don't want to go, because it involves, I'll tell you why I don't want to do it, because it involves indeterminate form. It's a limit that you have to calculate. It's an indeterminate form that you probably not have seen. I at least never teach that particular indeterminate form. So it's very difficult to solve if you don't know how to do this. So let's not do this. It's never going to happen on a quiz or on the final exam. So, but this kind of thing I want you to do. Okay. So I'm going to solve this one. Now, since I didn't assign it, stop the video and try to solve it for yourself, and then look at your solution that I'm going to write down now. I'm sorry about that. If you have the time for that, do it. It's always better to practice as much as you can. Okay, so how would it work? Well, there are two things. We have the ratio and root test, but we have said root test only we will use if everything is a power of n. Now, this is a power of n, but this is not. So, no root test. So what we're going to do is the ratio test. And remember the ratio test, I'll write down the formula for it. It's the limit for n going to infinity. In the bottom goes the formula that you have, and in the top goes the same formula with an n plus 1. And there's also one thing, you have to do absolute values. And then there are three possibilities. Either you're less than 1, then you're okay, that's convergent. You're bigger than 1, then you have divergent. But the worst case, if it's equal to 1, then it's inconclusive. Meaning you should not have used this test. And this happens, right? Be careful with that. And soon I'm going to do a review for quizzes and so, where I will tell you how to make a distinction between what type of test to use. So ratio test, should I use integral test, should I whatever test you use. But for now, we know what it is, ratio test that we're going to do. So what we do, so we have to calculate this limit. So you always start with writing down the actual formula that you have. Okay, so you write n factorial over pi e to the power n. And then on top gets the same thing, but replace every instance of n. This is an instance of n, and here is an instance of n. So both have to be replaced now with n plus 1. So we get n plus 1 factorial, and then in the bottom with pi over e n plus 1. Okay? And the whole thing has to have absolute values, but since everything is positive anyway, it's okay to leave them out. Okay, I'm going to write them in the next step. I'm not going to write them anymore. Okay. We simplify this fraction in the usual way, flipping over the denominator. So what we get, the n plus 1 factorial is on the top. This guy will go into the bottom, but I'm going to remember it's also helps to kind of align things already, because there's two more terms going to come in, right? This factor here, the n factorial, is going to go in the bottom, whereas this one in the bottom becomes top 1. So pi over e n plus 1. And the reason that I group them is because there are cancellations in each of these groups. So what are the cancellations here? Well, first of all, the easier one, oh, sorry, I copied something wrong. That was power n. No, I copied wrong, right? This one here, this was the one in the bottom. This is supposed to be this one, okay? It's power n, not n plus 1. See, I know this was wrong, because if it would have been true, then everything cancelled. And I know this never happens, right? Come on. That's too easy. And so, okay, so what cancels? Well, we have a power n and a power n plus 1 here. The base is, okay, you think, oh, what to do with the pi over e? No, it's just a number. Whatever it is, we don't care about it. It's just a number. It's a base exponential function with that base. And the way you cancel is subtract exponents. And the biggest exponent is at the bottom. So let's put everything in the bottom. So after cancellation, we have just one power left of whatever the base was, pi over e. Okay. Now n plus 1 factorial, I'll write it here. This is the top has the biggest factorial. And we always write the biggest factorial in terms of the smaller factorial. So what is the difference between this factorial and this factorial? There's a bit more missing here, right? What is missing? Well, to go from, this factorial says I have to go from 1 to n plus 1. Here I have already gone from 1 to n. What I'm missing is n plus 1. Now we have to multiply, so that's why I have parentheses there, okay? So this is how you break down these factorials. I'll do another example, one that I didn't really assign, but just to show you how it works. Okay, so limit n going to infinity, we have this n plus 1 factorial breaks down as n plus 1 times n plus 1. Then we already cancelled the top there, and then in the bottom, this n factorial, and we have also this pi over e. And now the n factorials cancel as promised, and so what we left is n plus 1 in the top and pi over e in the bottom. But that's okay. If I now take the limit and plug infinity, I get infinity. On the bottom is some number, who cares what it is. It's infinity. So, well, infinity is definitely bigger than 1, so this is divergent. Okay? So let me do the other problem that I assigned first, and then I'll give you another example of the... Well, let me do that first here. So, new example, new problem. So again, stop the video and try to do it first for yourself and then look at the solution. Okay, so the one I want to do is this one here. Summation, what is it here? Yeah, n factorial 2n plus 1 factorial. Something very similar we did in the previous video. Okay, again, ratio test we're going to do. So ratio test. And I can tell you now, whenever you have a factorial, don't even think about anything else. It is ratio test. Okay? All right. And you'll see in the next lectures, you'll see that the ratio test is our preferred test. Today's lecture already, you will see it. Okay. All right. So what do? We take, again, this limit for n going to infinity. In the bottom goes this expression, n factorial 2n plus 1 factorial. Okay. Now in the top, there are absolute values, but everything is positive, so I'm not going to write those anymore. Now in the top, every time I have an n, I'm going to replace this n plus 1. So let's do this in different color, right? This n becomes an n plus 1, and then there's a factorial sign. But if I write it this way, if you're really picky, you say, oh, it's n plus 1 factorial, and 1 factorial is 1. No, we mean n plus 1 factorial. That's... Put parentheses, okay? They are still for free, although the college is closed, you can still get them for free. All right. The same, of course, here. So n plus 1 factorial. The trickier one is this one here. Let's see. This is the n. So we have a 2, and that's here. Here was the n, and that now becomes an n plus 1. And what else was there? A plus 1. And then we take factorial. That was in the denominator. Okay? Take your time. If you, of course, once you're used to it, you know exactly what is in the bottom is. So let me rewrite it a little bit. Okay, and in the meantime, already take care of the fraction. So we have these two guys going on top, n plus 1 factorial, n plus 1 factorial, and then this guy will be in the bottom, right? So, in the bottom will also be on top. So there's a 2n plus 1 factorial here. And then these two n factorials are here. I group them together with this guy. So what is this now? Well, let's work it out. We have to distribute this one. That's 2n plus 2 plus 1. So it's really 2n plus 3 factorial. Okay? And now we do this same thing. The bigger factorial in terms of the lower factorial. And again, we have grouped these things, right? So it's in each of these three groups that I'm going to look at what's the biggest. The first two is the top, and in the last one, it's the bottom. Now, n plus 1 factorial we have already done. We know how to rewrite this. Okay? So let me start doing that here. I'm going to give myself a little more space. So I know that n plus 1 factorial is the same as n factorial times n plus 1. That's true for the first one. It's therefore also true for the second one. Now, the 2n plus 1 is the smaller of the two here, right? Among these two, it's the smaller, so I leave that. Okay, in the bottom I also leave the n factorial, I leave the n factorial. So now this one. Well, I have to break this down into 2n plus 1 factorial, the top one here, and whatever is now left. Well, what is left is, remember, in a factorial you go from 1, the started 1, and go all the way until the number. So here in 2n plus 1 factorial, I've gone all the way to 2n plus 1. But that's not where I should end up. According to this, I should have a 2n plus 3. Now you go up by 1. So if I go from 2n plus 1, the next one will be 2n plus 2. Am I there? No, because I need to be in 2n plus 3. So you keep going until you're there. Oh, no, now I'm here. Okay? And that's how you break these two. And so even if you have like 3 factorial, then would be try out what happens. So there's a question like that. I think 322 you could try. It's similar, but even a bit more work. Okay, so quickly now, because we are now almost done, because these cancel, and this cancel. In fact, if I be a bit smart here, and I see this is actually 2 times n plus 1, right? This is 2 times n plus 1. So if I cancel with that, I will only have a 2 left. It makes it a little bit easier, not necessary, but makes it easier. So what do I have now? On top I have only n plus 1 left. In the bottom I have that 2, and also a 2n plus 3. And then we do our usual trick, divide top and bottom by the highest degree, or you can do L'Hopital, that's fine too. But again, dividing by the whole top and bottom is the highest degree here, both are linear, so both is degree 1. So this is the way that we calculate limits, right? If you're wondering what this all of a sudden comes from, this is just a technique we always have used to calculate limits of this form. Okay, so what we get, it's the limit for n going to infinity. We now divide everything by n. So here everything is by n. This is 1 plus 1 over n. And in the bottom we get, well, the 2 is a 2. And then inside we divide 2n divided by n is 2 plus 3n. Why do we do this? The reason that we do this for this kind of limit is because then these reciprocals, when you plug in infinity, go to 0. And so you're left with 1 on top, 2, and another 2. So 1/4. And now we just look, what is 1/4? Well, it's in this situation. So we have convergence here. Okay? So that's how you deal with factorials. And so I did assign also, I think 330 is an example, just to have one, of the root test. And so why is it a root test? Well, let me write down the example, then I'll explain why it's a root test. So it is summation ln of n to the power 2n divided by n to the power n. There's a lot of n's there, and it looks awful, and it could be very awful, but luckily what we have is we have a power of n. Well, you say, it's a power of 2n. Yeah, yes and no, because you have these rules of powers, right? You can rewrite this, and it might be useful to do that. This was from n going, I don't know anymore from where we were going, from 1, yeah, from 1 to infinity. So you can break down this power as follows. Because a power of a power, what you do if you take a power of power, you multiply the exponents, right? These two exponents becomes this exponent. And so now you see better that this actually was an n power of what? Of this thing inside here, this ln squared. Okay, so I'll get a little bit of my scratchings. Okay, and then in the bottom we have n to the n. So just to emphasize this whole thing, let's write it as a single n power, because again, one of the rules of powers is that in a fraction you can combine, if they're the same exponent, you can combine top and bottom. So this becomes ln n squared, and in the bottom you have an n. Okay, now the root test. So why am I saying now root test? Because I have an n power here. And the root test says, well, what you do is you take the limit infinity. In general, you would take the nth root of the absolute value of n. Again, absolute value, because otherwise roots of negative numbers can be very cumbersome. So in this case, this will be the limit for n going to infinity, the nth root of the absolute value, but are again positive numbers. So here we have ln n squared over n to the power n. Now the whole deal, of course, is that the nth root and the n power cancel each other out, right? This nth root and this n power cancel each other out. So we're left with the limit, whatever it was underneath the radical, ln squared divided by n. If I plug infinity, oh, bad news, it becomes infinity, right? Over infinity. So what we do? Lop it up. Okay, so we can, well, technically we should first write it as a function now over x, not just a series. So ln x squared over x. And now we're going to take the L'Hopital, which means that we're going to take the derivative of the top. Now, it's power of a function, chain rule. Don't think that you have to forget the chain rule, right? You always need the chain rule. So derivative of a square is 2 times whatever the inside function was. And now you multiply by the derivative of the inside function. Okay, that's the derivative of the top, and the derivative of the bottom is just 1. Oh, okay, I should be done. This time you got a little bit bad luck, because if I plug infinity, I get again infinity over infinity. Right? This 1 over x, yeah, perhaps going a little bit fast, so let me show it again. We can rewrite it this way, right? If I plug infinity here, I would get in this form, this would be infinity, but 1 over infinity would 0. And 0 times infinity is an indeterminate form. Now, I'd rather do this one, because then it's L'Hopital form, right? Infinity over infinity is one of the L'Hopital's forms, so I have to do L'Hopital again. This is not the first time you've seen this, right? That you sometimes have to do L'Hopital several times, okay? And because I know I'm going to get better, right? The first time I had a square here, and now I have only this one left, and I went one more step, and this is what I'm left, and now I plug in infinity, I get 0. So what does this all mean? Well, the root test, what was the conditions for the root test? They were exactly the same. So I'm making a bit lazy here. These are the exact same conditions here. So we are less than 1, 0 is less than 1, so we have convergence here. Okay, so we're going to have a quiz soon on this thing, and then also, yeah, so there's going to be a couple of quizzes testing on this series while we with the new material on chapter 6. Okay.